Okay, empirical and molecular formulas. A molecular formula is the exact whole number ratio of atoms within a molecule. For example, water has the molecular formula of H2O. Benzene is C6H6. So an empirical formula is the simplest whole number ratios of atoms or ions in a compound. So this sometimes is not the correct molecular formula for the compound. It's just the smallest whole number ratio of atoms or ions in the compound. The empirical formula is determined by observation during experiments. That's why it's called empirical, because it means observed. Empirical formulas give us the ratio of atoms, but not necessarily the correct number of atoms in a chemical formula. It can be used to find the molecular formula if the molar mass of the compound is known. Calculating the empirical molecular formula. So, first thing you do is you assume a 100-gram sample and you write that down. Assume a 100-gram sample. And the reason we do that is because it's a quick math to convert between a percent and a mass, because we need to find moles. So if we have 56% carbon in our sample, then there will be 56 grams of carbon in a 100-gram sample. So second step is we calculate the moles of each element, and then this is the important step. We divide each mole's amount by the smallest number of moles to get the ratio of each element to each other. And this ratio is our empirical molecular formula. To determine the molecular formula, once you have the empirical formula, you calculate the molar mass of it, and then you compare this mass to the molar mass of the entire compound to get the multiplier. And then you multiply the empirical molecular formula by the multiplier to get the molecular formula. So let's say you figure out your empirical formula was CH2. That was your empirical formula. So then what you do is you figure out the molar mass of this. So it's 12.01 for carbon and 2.02 for the hydrogen. So we have 14.03 grams per mole for our empirical formula. Let's say the compound has the molar mass of 42.09 grams per mole. And you would have to be given this information. You'd be given the molar mass of your entire compound. So then you figure out how many times your empirical formula can go into the molecular formula. And you do that by dividing. And this will give you your multiplier. Units are the same, so they cancel. So our multiplier is 3. We can fit 3 14.03s into 42.09. So our actual formula contains 3 times our empirical formula. So CH2 times 3 is C3H6. So this is our molecular formula for our compound, whereas our empirical molecular formula was CH2. So simplest whole number formula, actual molecular formula. So let's do a couple of examples. What is the empirical formula for N2O4? What is the smallest whole number ratio there? Well, both of these numbers can be divided by 2. So if we take that and divided by 2, we get NO2. So this is the simplest whole number ratio of the elements in this compound. The multiplier is 2. So we would multiply this by 2 to get our molecular formula. C2H6. So both of these numbers can be divided by 2. So the empirical formula is CH3. Divide the 2 and the 6 by 2. H2O. Is there a number that can be divided into 2 and 1? Nope. So in this case, the empirical formula is the same as the molecular formula. So sometimes you can reduce the molecular formula to an empirical formula, and sometimes you can't. In that case, the molecular formula is equal to the empirical formula. What is the empirical formula for a compound whose percent composition is 79.9% carbon and the rest is hydrogen? All right, so assume a 100-gram sample. That's a mark right there. So for carbon, we have 79.9 grams of carbon, and that must mean we have 20.1 grams of hydrogen. Now we need to find the number of moles, so take those numbers and divide by the molar mass of each of those elements. And gives you the moles of each element in the compound. So 6.6528 moles of carbon and 19.901 moles of hydrogen. Now what you need to do, we found the number of moles, now we need to find the mole ratio. So which one of these is the smallest number? Well, it's the 6.65. So you take each one of these moles and divide by the smallest number. And this will give you your mole ratio. So there's 1 carbon and there is 3 hydrogens. So the empirical formula is CH3. It says that the molar mass of the compound is 30.0 grams per mole. What is the molecular formula? So what is the molar mass of our empirical formula? You've got 12.01 for the carbon, 3.03 for the hydrogen. So in total we have 15.04 grams per mole. So 30 grams per mole divided by 15.04 grams per mole, and that gives you a multiplier of 2. So therefore the molecular compound, the molecular formula for the compound is 2 times CH3, so C2H6. You take the empirical formula and you multiply by the multiplier to get your molecular formula. Now, sometimes the mole ratio doesn't come out as a whole number. And you can't just round this off. If you get 2.3 moles of carbon, you can't round that to 2. That's 2 1/3. So what we do, when you end up with mole ratios of numbers like 0.33, 0.65 or 0.66 or 0.5, you're going to recognize these are fractions. And when you get these, you must multiply them by the denominator to get the whole number. For example, 4.85 moles of hydrogen and 1.823 moles of carbon. So let's find out what the mole ratio is, because this just gives us moles. Divide by the smallest number, and this will give us the mole ratio. So this means 2.66 hydrogens for every 1 carbon. Well, you can't have 2/3 of a hydrogen atom. So what you do, that's the same thing as 2/3, 0.66, the same thing as 2/3. So if we multiply by 3, we get rid of the fraction. You can't just multiply one of the mole ratios by the number, though. You have to multiply both of them. So I'm going to take this and multiply by 3, because that's my denominator. So 2.66 times 3 is 7.98. When you're off by a few 100ths in a decimal place for the whole number, you can round those off. So that's 8. And then 3 carbons. So your formula then is C3H8. 3 carbons for every 8 hydrogens. So that is how you calculate empirical formulas and molecular formulas.